So in our last lesson, we have done introduction for the vectors, and we have the geometric vectors and also algebraic vectors. And the geometric vectors is just any vectors. There is no xy coordinate system, and algebraic vectors is we put the vectors in the xy coordinate system. And from now on, we are going to focus on the algebraic vectors because we have seen from our last lesson, it's easier for us to do the calculation for the resultant vectors from the algebraic vectors. So let U be a vector in the plane and move the U until the tail to the origin. Then that is in algebraic vectors in the xy coordinate system. And always we could write it as xy coordinates. So A and comma B. So this one is like a point, but now this is not a point. This represents a vector with algebraic vectors. So, and its magnitude, we use absolute value, the U vectors as a length for that vector, and the direction theta is given by the equation, the opposite over adjacent. So opposite is B, adjacent is A, so B over A. So this is either in ordered pairs, or you could give the magnitude and the angle both represent a vector. So theta measures counterclockwise from the positive x direction. We call it principal angle. And this formula will give you two values of theta. So for tangent, we know that is if tangent is positive, it may be first quadrant, maybe the third quadrant. So we need to see, we call this related acute angle. Then based on the quadrant, we decide which quadrant, which angle we are going to use. For the first quadrant, the angle is equals just a related acute angle. And the second quadrant, the principal angle is 180 pi minus RA. For the third quadrant is pi plus RA. This is our principal angle. And for the fourth quadrant is 2 pi minus RA is our principal angle. So then from here you will see always we want to find the related acute angle. Related acute angle, how to find it? It just use a positive A and B. Because related acute angle is from 0 to 90 degrees, so the tangent will be always positive. And beyond that is unit vectors. Unit vectors means magnitude is 1. So we know the U magnitude is U absolute value, so we divide it, then we will have just a magnitude is 1. And only with a direction. So vector, we could write it as a magnitude, then times a unit vector. So now we are going to see example 1. So the position vector of a point P is a vector OP from the origin to the point. So this is a point -3, 7. If without this P, it will be a vector. So if we draw it, it will be in the x is negative, So -3, y is positive, so it will be in the second quadrant. So from O to P is this the vector. So this one we call component form. And before is a point, now it's represent a vector. It asks us to determine the magnitude and the direction. So magnitude is from O to P. Then this is 7, this is -3. In this triangle, we have the a squared plus b squared equals c squared. So the magnitude is just a squared plus b squared, then square root. So magnitude, we use absolute value sign with the OP here is our magnitude equals square root a squared plus b squared equals -3 squared plus 7 squared, then equals 58. We could round it as 7.62. And after that, we are going to find the angle. So the direction. So we want to find the related acute angle first. So tangent inverse BOA. We use absolute value, the positive number only. So tangent -1, B is 7, positive number only, over 3. Then we find the RA is 1.16. So this angle is 1.16. Then the principal angle is from x positive direction to here. It will be 180 degrees is pi. So it's pi minus this one give us that. So the second quadrant is pi minus. So the angle is second quadrant. Quadrant second is pi minus RA. Give us around 1.98 in radians. And if we want to change it to degrees, you don't have to. So if we want to change it to degrees, 1.8 times, here we put pi, 1 pi equals 180 degrees, radians at the bottom to cancel out, then we have degrees left is around 113 degrees. Then this is our direction. So this is just, before is a point, now that bracket represent a component form. So we call it component form, x component, y component form. And for this vector also, we could write it as 7.62. Then we put the degrees, 113 degrees. This is magnitude and degrees. Okay, so this is we want to find another way to write it is this is component form, and we also want to could use another form, use unit vectors to write it form. So it's in the OP equals AI plus BJ. So A direction plus B direction. For this one, we could write it as OP unit vectors. OP equals A is -3 x direction plus 7, then y direction. So this one is another notation. We could use unit vectors to write it. So x direction, we use I to represent it. And y direction we use 0, 1, this direction to represent it. This is our unit vector for y direction. This is our unit vector for x direction. So we want to just practice on rewrite it in the unit vector notation. Okay, so this is x direction, this is y direction. What we want to write is just 2i, 2 unit direction I, 2 in this direction, and -3 in the y direction. That is done. And this one is -10 I direction plus 20 j y direction. So that's it. And I want to put one more practice. If we want to put these two, the sum of these two, so sum of a plus b, then what we could write is 2i minus 3j plus -10i plus 20j, then collect the like term. I, same thing. 2 minus 10 give us -8. J -3, 20 is 17. Then it's done. So this is another way we can do the sum of the resultant, sum of the vectors by using the unit vectors notation to do it. And example 3 is the next one. So the geometric vector v is defined as magnitude is 10, direction is north 45 degree east. It asks you to find the components of the position vector, so it just means you find x component, y component. So we want to put it in the xy coordinate system. So this is x, this is y, north 45 degree, this is north, this is south, east, west. So north 45 degree is here, then this is 10. So this is our vector, and we want to find out the x component and y component. So same as before, we want to find the angle found with x-axis. So 90 minus 45 is 45 degrees. The reason why we want to find this angle, because after that the x component is just the magnitude times cosine this angle, and y is the magnitude times sine that angle. Then just get your calculator out. It's approximately 7.07 in components. So we want to write it as 7.07, 7.07. This is a component vector. This is our component vector notation. And if we want to write it as a unit vector notation, then we just write it separately. This is x direction, this is our y direction. Okay? So if you are confused with why the x direction equals this one, we could draw this one is a right angle triangle. So this based on 45, this is opposite, this is adjacent, and 10 is hypotenuse. So the sine equals opposite over hypotenuse is y over 10. Then we move the 10 to other side. We have y cosine 45. And for the cosine, it's just x over h. So then you could find, okay, this is a cosine, this is sine. So that is for the two-dimension. We have learned the component vector and notation and the unit vector notation. Unit vector is x direction, unit vector is I, y direction, unit vector is j. Okay, and next one, three-dimension. So three-dimension, we just use ABC. This is x, this is y, this is z in three-dimension. And the unit vector form is just x direction is I, y direction. So this one, x unit vector is I, y unit vector is j, and z unit vector is k. So for the point 6 to 4, we go on the x6, then go along y2, then up 4. This is 6 to 4. So this means x direction move the 6, then y direction move 2, then z direction move 4. Then we are going to, it asks you to find the coordinates of A, B, C, D, E, F. Okay, so for the A, it's only on the x direction. There's no move right, no move up. So this one is kind of move to the front. Front 6, so A is just 6, then no right, no up. And the B is 6, then move to the right, that is a y, and no moving up. C is move from A up 4, up 4. So 6, then up 4 is z direction. So this is a z direction is up, y direction is right, and this one is move to the front. Just count. And D is just move up, just a Z 4, no left right. So left front, left right, both 0, just up 4. E is right and up, right 2, up 4, and no front. So no front, front is 0, 2, 4. And F is here, so just move the right, no up, no front. So just y change to 2, 0, 2, 0. So this is how we write these coordinates up. This is a first one is a front back, this one is left right, this is up down for the z direction. And normally we put the z to be the up, then x, y. You could follow the right rule, so you hold your hand, right hand, then your finger from x to y, this rotation, then the thumb pointing to the z direction. So this is your thumb. This is your finger wrap from x to y. So x, y, then z. And it asks you to draw the vector OP. So it's just from here, the origin, just draw it to P. This is your vector OP. And the magnitude is given by a squared plus b squared plus c squared, then square root. You could use 2 right angle triangle to find it. So this is a xy, so you have this Pythagorean. Hypotenuse is x squared plus y squared, then square root. then you add this z. So x squared plus y squared plus z squared give you this hypotenuse. So use Pythagorean theorem twice. This squared, then plus z squared again. It will give you the OP squared. Then locate the point P, sketch the position vector OP in 3 dimensions, and calculate its magnitude. So this one you will do it will be you get the xy direction. So this is z, this is x, this is y. Then -5 means go into the page file. -7 is go to the left 7, then up to. So this is kind of, this is your P. So it's inside to the page file, then go left 7, then go up 2. And the vector is just from the O to P. So this one is just, we could write in file, left 7, then up 2, okay? And this one, -3, -2, 5, this one is inside the page 3, left 2, this one is up file, okay? So if we draw it, x, y, z, -3 go inside, then left 2, then up file. This is your P value. Point P, then from O to P, then just draw from O to P. This is a vector OP, okay? So now we are going to see the last example. So representing planes. So planes means it's just a 2-dimension and is a flat surface in 2 dimension in the 3 dimensions with equation. The point Q is 2, -3, -5. So this is x, this is y, this is z. So 2 to the front, 3 to the left, then 5 down. This is a point. It asks you to write an equation for the xy plane. So xy plane is this one, and in the xy plane, xy could be any numbers. And at the xy plane, the z, no up or down, so z is 0. And this one, xy could be any number. And the xy could be any numbers. It forms a flat surface. We call it xy plane. And z equals 0. This is a first equation for a plane in 3 dimensions. And question B. Write an equation for the plane containing the points P, M, Q, T. P, M, Q, T. So this is this plane. And in this plane, you will see that the common one will be the y value same. This is a plane that is moved 3 to the left for the xz plane. So for this plane, the common is y equals -3. And for this plane, as long as y same, xy could be any numbers. It's a infinite flat surface. And on that surface, y value same. So this is y equals -3 and xz could be any number, any combination works. This is represent a plane. And question C, set of points in rectangle PMQT. So a mathematical description of the, okay, so if we restrict this plane only to this rectangle, then it will be y equals -3, but you cannot have x, z, any numbers. X is from 0 to 2. So x value is from 0 to 2 and the y value is -3. The z value is from 0 to -5. So negative minimum to maximum. So this is a restriction for the set of points, not all points on this plane, but only this rectangle part. So question D. What's the equation of the plane, parallel to the xy plane and passing through the point 0, 0, -5? So equation of this plane, you will see on this plane all the z value. So it's just xy plane down 5. So this is another plane. So it's down 5. Z all value is -5. And for this one, xy could be any number, any combination. If xy could be any numbers, it represents a flat surface. It's parallel with the xy plane. Okay, so in this lesson, what we have done is we have extended the vectors from 2 dimension to 3 dimension, and we introduce a unit vector. Unit vector is magnitude is 1, but the direction is in the vector's direction. And the magnitude for a vector is a squared plus b squared, the x component squared plus y component squared, then square root. The angle is just inverse of tangent BOA. We always want to find the related acute angle that is 90 degree, 0 to 90 degrees, then based on the quadrant to find the principal angle. Principal angle is always from x direction, positive x axis, and counterclockwise turn. So principal angle equals RA, related acute angle in first quadrant. In second quadrant is pi minus this one to get the principal angle. And the third quadrant is pi plus RA to get the principal angle. The fourth quadrant is 2 pi. It's a whole circle 2 pi, 360 degrees minus RA to get the principal angle. And after that, we also have learned the component form. It's just x component, y component, and unit vector notation is x, and then I unit vector for x direction plus y component, j unit vector for the y direction. We call it unit vectors. So when we add subtract vectors, we just add subtract the x component or y component correspondingly. And a geometric vector, we put it in the xy coordinate. The tail put at 0 origin, and after that, the x direction component is just magnitude times the cosine the principal angle formed with x axis, and y direction is just magnitude times the sine that principal angle, then give you the y component. So for component vector, we just write x coordinate, y coordinate. Unit vector, we write it as x I direction plus y, then j direction unit vector. So for the unit vector, actually, you could just use this small height instead of the arrow to represent this is a unit vector, okay? So sorry about it. It's unit vector, we use a small height. This is unit vector. Then just the 3 dimensions. The first one is x component, second one y component, third one is z component. If we use a right hand rule, this is x, this is y, then our finger from x to y direction to wrap it, then the thumb pointing to the z direction. So if we draw it this way, then x is front back, y is left right, z is up down to draw the point. Then for the plane, it's just if it's parallel with one of the xy axis, the direction the equation of the plane is very easy. It's just one coordinate equals a constant. Okay, so that is all for today's lesson. Thanks for watching.